Good evening, ma'am.
Sai Kalyan, are you there? Hello? Sanjay, good evening. Are you there?
Good evening, ma'am.
Sai Kalyan, are you there?
Yes, ma'am.
Good evening.
Good evening, ma'am.
Okay, so at least 3 of you are there, so we can start the class now. I don't know whether others are coming. No, others have come. Somebody else, Hariharan has also come. Okay, so we'll start the class. So today we are 6 minutes late. Okay, so for today, before we start, I thought we should do a few questions for revision. Okay. Now, before I start, I have a request to all of you. The request is that if for any reason you leave the class, then you must inform me. Switch on your mic and camera and tell me, ma'am, I have to go, or if there is some other reason you have to leave, you should take permission and then leave. Suddenly somebody leaves from the class and then later after 10 minutes only I realize one person is not there. So if you are leaving the class, please take permission before leaving. I cannot stop anybody from leaving, but I don't like people leaving the class without informing. So please inform and then leave. You can write a note in the chat and say, ma'am, I have to leave for some reason. I don't even ask for reason, but at least you need to take permission. Supposing we were having an offline class, would you get up and go out of the class without telling me? Or would you just go out of the class without taking permission? So it really feels bad if you go without telling. At the end of the class, sometimes I realize only 3 people are there and you all leave. So you can say, good evening, ma'am, we are leaving, thank you. Something you should say. You are young children. These basic ethics you should learn. These are very important for the rest of your life, right? Do you agree with me or not? First of all, none of you switch on the camera. Sanjay used to switch on the camera. Today, Sanjay has also decided not to switch on. So for some time, you should switch on the camera. Vaishnavi?
No, ma'am.
Yeah,
Actually, I'm
please.
having a
At
power
least when
supply,
you
so
say,
I'm.
when you join the class and when you say good evening, at that time, you should switch on the camera. It is very important. After that, in between the class, you don't want to switch on, I understand. But otherwise, 2 requests I have. When you start the class, you say good evening, please switch on the camera, say good evening when I start the class. And when you are leaving, please leave a message. You say, ma'am, I have to leave, and then you go. Otherwise, don't leave the class without telling me. If you leave the class in future without informing, supposing the current goes, I understand. But then as soon as the current comes, you can write a message and say, ma'am, I had to leave because the current had gone. So please cooperate. Otherwise, when I have a parent-teacher meeting, I keep a note of everyone who leaves without informing. I'm going to inform your parents. Every time it cannot be. Some children, as a matter of, habit, just suddenly in the beginning of the class, they come, suddenly they leave. So that is not fair. That is not good. Your parents are spending a lot of money to make you attend these classes. So it is up to you to make the best use of it. Understood? Okay, now we will start. See, Vaishnavi has switched on her camera. Nobody else has still switched on. Sai Kalyan, what is the problem? Why can't you switch on the camera for a minute at least?
I'm having a small internet issue. I will resolve it and switch it on.
Okay. What about you, Sanjay? Today you have not switched on.
No, ma'am. Today actually I'm attending from outside, ma'am. I'm not in the house, ma'am.
Okay. Hariharan, what happened to you? Good evening, first of all. Hariharan, are you there? How will I know that you are there? No reply. Anyway, I'll continue with the class. I'll make a note of all this. Okay, so we have this question. Last class, we were doing Grignard reagent, right? In the last class, we
Ma'am,
were
can you hear me,
doing.
ma'am?
Yes.
Ma'am, I have some Wi-Fi problems, ma'am.
Okay. Who is this? Hari Raghav?
I'm Hariharan, ma'am.
Hariharan. Okay. Hari Raghav, good evening.
Good evening.
Good evening. So when you say good evening, I was just telling others, when you say good evening, please switch on the camera and say good evening, ma'am. And then you can switch off if you want, right? Because it is very difficult to teach a wall, nobody, I don't see anyone and I continue to teach it. It's very difficult to do that. Okay. Now here you see, we in the last class, what were we doing? We were doing Grignard reagents, right? We were doing Grignard reagents and we did this reaction of Grignard reagent with the first reaction of Grignard reagent with formaldehyde. And I showed you how with the help of formaldehyde, you can make all primary alcohols. The alcohol that you make depends on the Grignard reagent. So one reagent is formaldehyde or methanol, and the other one is a Grignard reagent. So if I take Grignard reagent and methyl magnesium bromide, I will get ethanol. If I take ethyl magnesium bromide, I will get 1 propanol. If I take this one with the Grignard reagent, then I will get 2 methyl 1 propanol. So I get all primary alcohols if I take formaldehyde and Grignard reagent. So my next question is based on that only. How are the following alcohols prepared by a reaction of suitable Grignard reagent and methanol? So they both are primary alcohols. So one reagent is methanol, right? What is methanol? CH. One is CH2 double bond O. The one reagent is CH2 double bond O. Now, what is the Grignard reagent along with that we should use to get the first compound? Who will tell me? Vaishnavi, can you tell me?
Yes, ma'am.
Yeah.
CH3, CH, MgBr, and in the second CH, there will be
Yes. Yeah,
methyl.
very good. Very good. MgBr. And by doing that, we will get CH3, CH, CH3, and CH2OH. Okay. For the second one, this is the first one. For the second one, what will we do? Sai Kalyan, can you tell me what we will do? One reagent is CH2 double bond O. What should be the second reagent? Anybody else who can tell me? Sanjay, can you tell me? Tell me. Anybody?
Ma'am,
Tell me.
a ring mesh,
Yeah, a ring and then directly attach it to Mg,
MBBR.
right? So this will give you the ring here. No ring inside the ring. It is not a benzene ring. It is a cyclohexane. And here I will get CH2OH. Okay, so that is how you prepare primary alcohols. I hope you have understood. Now, this was the other question that we were doing. Write the structures of the products of the following alcohols. How will you prepare? What will be the products? These are all methods of preparation of alcohols, which we did in the last class. Now, tell me, what is the product that you will get in the first case? What is the product? Sanjay will tell me. What will I get when I add propene and I add H2O to it? Can you tell me, Sanjay?
And CH3CH2 double bond CH2, ma'am.
The first one, CH3CH double bond CH2, I want to add to it H2O. When I add water, what will I get?
CH.
See what H2O is what? HOH. So on one carbon, I will put OH and on one carbon, I will put H. So where will OH come? Here. See carefully.
Yes, ma'am.
Right?
OH.
And CH. So you got 2 propanol. You will get 2 propanol. Now this one here, I am reducing it with NaBH4. So what does NaBH4 do? I told you it will change wherever it is an aldehyde or a ketone. H will add on the either side. It only attacks the carbon oxygen bond of aldehyde and ketone. So where will H add? Only here. So what will be the product? The product will be on that carbon oxygen bond. I can add H on both sides. It will become OH. And this will remain as it is, CH2, C double bond O and OCH3. This will not change. Why? Because NaBH4 only reduces carbon oxygen bond, right? So that is a product. Now here, when I add NaBH4, what is it?
Side ring. Ma'am, in the case of the side ring, we have another C double bond.
Yeah, but this C double bond O is not a part of the aldehyde or a ketone. How will you recognize that? If on C double bond O, there is a C double bond O, it can be present in many ways. On both sides, either there should be a carbon, then it will be reduced by NaBH4. On C double bond O, on one side, if it is H, on both sides, if it is hydrogen, then also it will be reduced by NaBH4. If there is a C double bond O, one side there is a H and one side there is a carbon, then also only in these 3 conditions NaBH4 will reduce. Now supposing there is a C double bond O, on one side there is a carbon and the other side there is an oxygen, it will not reduce. This will reduce, this will reduce, this will reduce. This will not reduce. If there is a C double bond O, on one side there is a H and the other side there is a O, it will not reduce. If there is a C double bond O, there is a oxygen on this side and a oxygen on this side, it will not, there's a OH on this side, it will not reduce. Okay, it will only reduce when there's a carbon on both sides, or there's a hydrogen on both sides, or one side there's a hydrogen, on the other side there is a carbon. That means it should be either an aldehyde or a ketone. Did you understand? This case, it can be an ester, it can be an ether, it can be an acid, they cannot be reduced by NaBH4. So here what is happening, on one side there is oxygen. So that will not be reduced. Only this one will be reduced. Now let us see the next one. In the next case, there is CH and there's a double bond O here. So it is one side oxygen, the other side carbon, the other side hydrogen. So CHO can be reduced. So what will I get? CH3, CH2, CH here, CH3, and here what will you get? CH2OH. Okay, so now it will be reduced. Why it will be reduced? Because it was CH on one side carbon, one side hydrogen. Okay, so that is why. So this was another. Now there are a few MCQs. All of you please pay attention and tell me whether you can answer. Monochlorination of toluene in sunlight followed by hydrolysis with aqueous NaOH. What will you get? So I'll take toluene first. This is toluene. Okay, this is toluene. CH3, methyl benzene. It is known as toluene. Now, when you do monochlorination in presence of sunlight, so chlorine in presence of sunlight, what does it do? It can always cause substitution at the carbon chain. Side chain of the carbon will be substituted. I will get CH2Cl. And when I do aqueous NaOH here, what will happen? Cl will be replaced by OH. So what will I get? I'll get CH2OH. What is CH2OH? Benzene ring and CH2OH. What is it? It is benzyl alcohol, right? It is benzyl alcohol. You are going to get this PPT, so you can see it at that time. I will also try to send some questions through Mr. Bhaskar. He will send all these questions to you, so don't bother. You just pay attention. How many alcohols with molecular formula C4H10O are chiral in nature? Chiral means which have a asymmetric carbon atoms. So with C4H10O, if you remember in the last class, we wrote 4 alcohols. So I will write all of them here. CH3, CH2, CH2, CH2OH, 1 butanol. Then the second one was 2 butanol. So CH3, CHOH, CH2, CH3. The third one was 2 methyl 1 propanol, right? And the third one was tertiary alcohol. These are the 4 that we wrote for C4H10O. Now look at them one by one. You have to find out a carbon which is chiral. What is a chiral carbon? Sai Kalyan, what is the meaning of a chiral carbon?
Miss, different atomic groups on phosphates.
Different?
Atomic groups.
Different atomic groups attached to one. All 4 groups attached to the carbon atom should be different. So this carbon, is it chiral? No. This is also not chiral. This is also not. This is also. So this is not a chiral molecule. Now look at the first carbon. This is not chiral. Now look at the second carbon. What are the 4 groups present around it? One side is methyl. One side is OH. The third is H. And the fourth side is ethyl. So this carbon atom here is a chiral carbon. Okay. This one also doesn't have chiral carbon, and this one also doesn't. This is not chiral. This is not. This is not. Similarly, here also no carbon is chiral. So how many alcohols with molecular formula C4H10O are chiral in nature? Only one. Only one of these 4 is chiral in nature. Now, these are all CBSE questions. They are not JEE questions. They are CBSE questions. So you have to learn to answer them. The questions which are asked in CBSE are the same which are asked in JEE JEE mains and also NEET. Same questions, just from your textbook. So you have to do all of them. These are all from your exemplar problems. Now let us do this one. The process of converting alkyl halide into alcohols. Okay, so let me take an alkyl halide, CH3Cl plus aqueous KOH will give me CH3OH plus KCl, right? Now, Hari Raghav, can you tell me what type of reaction is this? Is it addition, substitution, dehydrohalogenation, or rearrangement? What type of reaction?
Ma'am, is it substitution?
It is substitution. Very good. It is a substitution reaction. Now, which of the following compounds is aromatic alcohol? Hariharan, can you tell me which is the
Yes, ma'am.
aromatic alcohol?
Aromatic alcohol, D, ma'am. Wait, ma'am.
B is aromatic alcohol.
No,
Other
no,
than
wait,
that,
ma'am. Can you hear me, ma'am?
yes, I can. So B is
Aromatic
definitely.
alcohols, ma'am.
B is B
A,
and
ma'am.
A, is it aromatic alcohol?
Oh, sorry, ma'am. B, C, ma'am.
B and C. So the answer is third one. Very good. B and C.
Yes, ma'am.
What is A and D? A and D are phenols. This is a
Phenols.
phenol. When OH is directly attached to the benzene ring. This is also a phenol. What are phenols? Where OH is directly attached to the benzene ring. Okay, now let us take the next one. Give IUPAC name of the following compound. Vaishnavi, now it's your turn.
Ma'am, is it 2-chlorohexane 5?
2-chlorohexane. Why? Where do
Oh,
you?
no.
It is hexane, correct. 1, 2, 3, 4, 5, 6. The numbering is wrong. So where do you give priority? Numbering goes to the functional group. So you have to number from here. The functional group should get the smaller number. So what will it become? 5-chloro.
5-chlorohexane.
Yeah. Hexane 2, right? Then IUPAC name of M-cresol. This is M-cresol. OH and meta position, there is CH3. What is the IUPAC name of this compound? Who will tell me?
Ma'am?
Yes?
3-methyl phenol, ma'am.
Very good. 3-methyl phenol. Excellent. Who is this? Sanjay?
Hariharan, ma'am.
Hariharan. Okay, very good, Hariharan. Okay. So so this just I did to brush up your chemistry, whatever we had done. Now we will continue with our Grignard reagent. Okay. So what did we learn for Grignard reagent so far? Preparation of alcohols with Grignard reagent. This is what we will continue. Okay, Grignard reagent in preparation of alcohols. So we have done one of them. What did we do? That when we take CH2O, that is methanol, an aldehyde which is methanol, and we react it with Grignard reagent CH3MgBr in presence of H2O and H plus. In presence of H2O and H plus, what do we get? We get CH3 from the Grignard reagent, and the rest of the molecule comes from the aldehyde, and you get CH2 and OH. Okay, CH3, CH2, OH. Now I am going to change my aldehyde. How will I change my aldehyde now? I am going to take CH3, CH double bond O. And I'm going to add CH3MgBr to it. CH3MgBr. right? Now you see what will happen. As I told, in this case, what was happening? CH3 was going and attaching to this carbon. Same way, CH3 will now go and attach to this carbon, right? And in presence of H2O and H plus, H2O and H plus, what alcohol will I get? Now write carefully. I will write first CH3. CH and O, right? On this double bond, I have to add two things. So what will I add on the carbon here? I will add methyl group on the carbon, right? This methyl group has come. And what will I add on oxygen? Hydrogen. So what alcohol I got now? I got a 2-propanol. 2-propanol. Right? And that is what type of alcohol? Secondary alcohol. Okay. Now I'll do one more so that you understand. Again, I will take CH3, CH double bond O. And I will change my Grignard reagent now. So what is a Grignard reagent? I will take CH3, CH2, MgBr. On doing that with H2O and H plus. Can someone tell me what I will get?
CH3, CH2, CH2Br.
Very good. Let us see. Let us write it. So first I will write here this compound, right? So I will write CH3, CH and O. Always what will come on hydrogen, on oxygen? Hydrogen.
OH.
And this group will go and attach on carbon. So what will I put in that group? I will put here. This whole group will come and attach here. So it will become CH2, CH, right? If I write it in a straight line, what is it? It is 2-butanol. So this is also what? A secondary alcohol. Yes, tell me.
Yes, ma'am.
Understood?
Yes, ma'am.
Okay. Now I will do just one more so that you understand it properly. This is because this part is very important. Now I'll change my aldehyde. So CH3, CH2, CH double bond O. And I will react it with CH. I will react it with CH3, CH2, MgBr, right? And in presence of, here I will write H2O and H plus, right? What will I get? Now how to get the product? I will first write this product completely.
Same again, CH3,
No,
CH2,
but it will be different. CH2, CH and O. First I'll copy this here and then I will write here what? H. And this
double bond in the O, right?
Yeah, it is double bond O that will become, when I add something on carbon and oxygen, the double bond will disappear, right? And I need to add this group on this carbon. So what is the group that I will put on carbon?
CH3, CH2.
Yeah, CH3, CH2. I will write it as CH2, CH. So what is this compound? 1, 2, 3, 4, 5. So it is 1, 2, 3, 4, and 5. 1, 2, 3. So this is 3-pentanol. Right? And 3-pentanol is also what type of alcohol? It is also a secondary, not tertiary. It is still a secondary alcohol. Why is it a secondary alcohol? Let me draw it in a straight line. 1, 2, 3, 4, 5. And here is OH. Can you make out? It is a secondary alcohol,
Yes, ma'am.
right? So what is the rule that you come out with? Now what I will write the second rule. What is the rule number 2? Rule number 2. What is the rule number 2? Aldehyde, any aldehyde other than formaldehyde. So RCHO, R can be anything. So any aldehyde and Grignard reagent will always give me what? Secondary alcohol. Okay. So an aldehyde with Grignard reagent will always give me a secondary alcohol. Okay. First, what did we learn? Formaldehyde plus Grignard reagent gives primary alcohol. Now, any other aldehyde plus Grignard reagent will give me a secondary alcohol. Okay. Now
Miss,
let us, yes, tell me.
Miss, here we are not here we are actually using the propanol, no, miss. If we are use CH3CHO only, we'll get, but here we'll get a tertiary alcohol only, no, miss.
No, tertiary you will not get. Where, how can you get a tertiary alcohol? Where on this carbon, there is only 2 carbon chains. Look here. Now you just wait. Now let me show you how you will get a tertiary alcohol.
Can you
Okay.
relate with that CH3, C double bond O and CH3 and explain, miss?
I will do. Okay. Now I will give you another example. This time I am taking a compound like this. I have CH3, C double bond O, and here also I have CH3, right? Now this compound is what? It is a ketone. How do you identify a ketone? On this carbonyl group, there are 2 methyl groups, right? Now I will add to it a Grignard reagent, right? So let me add a Grignard reagent. So CH3MgBr, right? In presence of H2O and H plus. Now what will happen? This CH3 will come and attach on this carbon. Okay, so how will I write the product? The product will be CH3, CH3, this part. And double bond will change into a single bond and hydrogen will come on oxygen. So this I will write as it is. Now what is the other thing which comes here? Here comes your methyl group from where? From the Grignard reagent. Now it has become a tertiary alcohol. This is a tertiary alcohol. Sai Kalyan, did you understand?
Yes, miss, this is tertiary alcohol. Then why the last? What did it did exactly did in the last case so that it's not tertiary alcohol?
In the last case, I had C double bond O and CH3. And here I had a H. It was an aldehyde.
Miss,
Right?
once again, can move to the last slide.
Yes.
Here you have done it CH3, CH2, CHO only, no, miss.
So it is now you see here. Now you see here, this H, if I write it separately. Right? Now can you understand?
Okay, miss. Yes, miss. Okay.
Okay, so this is an aldehyde.
Okay.
Here also I will write it separately so that you have no doubt. C and H here. So on this carbon, there are only 2 carbon chains. So it is a secondary alcohol. So now with ketone, we will make another ketone and practice. So I'll make here CH3 and here I will add CH2, CH3. And here I will add a Grignard reagent, which is CH3, CH2, MgBr. And I want to write the product with H2O and H plus. Now for writing the product, the best thing is you write this. This is not an aldehyde, sorry. This is a ketone. Which ketone is this? It is 2-butanone. Okay. So what will I do? I will write this whole thing as it is here. So CH3, CH, and here CH2, CH3. And what will I write here? This double bond will change into a single bond. It will become OH. And this group will come and attach on this carbon. So I will write that group on the carbon here. It will become CH2, CH3. So this has also become what? A tertiary alcohol. Now, what is the name of this tertiary alcohol? You can make out. This is the longest chain. No, I have made a mistake. There is no H here. So what is the name of this one? It is 1, 2, 3, 4, 5 carbon atoms. So this is 1, 2, 3. So this is 3-methyl 3-pentanol. So now we come across the third rule of Grignard reagent. What is the third rule of Grignard reagent? Third rule is a ketone plus Grignard reagent will always give me a tertiary alcohol. Will always give me a tertiary alcohol. Okay, so this part is a very important part. I took a lot of time to explain this. This will be again repeated in aldehydes and ketones because there it comes as properties of aldehydes and ketones. So I'll not teach again. Now you should remember, understand it thoroughly. Now we'll do a little bit more practice here. This time I'll give you alcohols and I will ask you to find out the Grignard reagent that will give me that alcohol. Okay, so we will write the alcohols now. So the alcohols are 4 alcohols of C4H10O. Okay, so one alcohol is CH3, CH2, CH2, CH2OH. The second alcohol, that is 1-butanol. The second alcohol is 2-butanol. The third alcohol is 2-methyl 1-propanol. And the fourth one is 2-methyl 2-propanol. These are the 4 alcohols you can make from C4H10O. Now, what is the combination of Grignard reagent and aldehyde ketone that you will use to get this alcohol? So how will I find out? Now, first thing you have to do is identify whether they are primary, secondary, or tertiary alcohol. See the carbon atom on which OH is attached here. OH is attached to this carbon, which is attached to only one other. So what type of alcohol is this one is? Primary alcohol. Okay. Second one. What type of alcohol is it? Sanjay, what type of alcohol is the second one?
Secondary.
Secondary alcohol. Then Hari Raghav, what type of alcohol is the third one?
Ma'am, is it primary?
Primary, yes, perfect. It is primary, very good. And what type of alcohol is the fourth one? Who will tell me? Vaishnavi, what type of alcohol is the fourth one?
Tertiary, ma'am.
It is tertiary alcohol. Okay. Now we have to learn to identify the compounds which will help to give. So the trick is the carbon to which OH is attached, you remove that carbon first. Remove this carbon. Here the carbon to which OH is attached, remove that one. Carbon to which OH is attached, remove that one. Right? Carbon to which OH is attached, remove that carbon. That is the first thing you do. Now what happens? In case of primary alcohols, you know, how am I going to prepare with a, so now you recall your 3 rules. What is the first rule? Primary alcohols is made by Grignard reagent and formaldehyde. So one aldehyde is formaldehyde CH2 double bond O. CH2 double bond O. Which is the other one? Here. So here also CH2 double bond O. Now the rest of the carbon chain has to be attached to what? The rest of the carbon chain has to be attached to the Grignard reagent. So right here, CH3, CH2, CH2, MgBr. So this combination will give you this alcohol. Now look at this one. Now this one here, you need to write any aldehyde and a Grignard reagent. So first what you do is, now you left this carbon atom. Now you see, you have to write one Grignard reagent. So write one Grignard reagent. Take the larger alkyl group and attach to the Grignard reagent. So what is it? CH3, CH2, MgBr. The other has to be an aldehyde. So take CHO and write the smaller alkyl group with this CH3, CHO plus CH3, CH2, MgBr. After you write, count the number of carbon atoms, they should be equal. So this has 4 and this has 1, 2, 3, 4. If you have same number, that means your answer is correct. Now here, which Grignard reagent? This rest of it will come to Grignard reagent. So CH3, CH, CH3 and MgBr. Now the third one is what? Here you need a ketone and a Grignard reagent. So first write the Grignard reagent. There are 3 alkyl groups. One of them used for Grignard reagent. And the other one you have to use for a ketone. So ketone has C double bond O and 2 carbon chains. So one is CH3 and the second is also CH. So you have taken care of all the alkyl. Did you understand now how to decide what is the combination of Grignard reagent and alcohol, which will give you a particular product? Okay, so both ways you should be able to identify the compound which react to give you the Grignard reagent. Okay, now if you have understood, shall I proceed further? So now we will do one more method of preparation. I think, is there anything else?
Ma'am, 1 minute, can I copy?
Yes, yes, please copy. Okay, shall I move? Sai Kalyan, are you done?
Yes, miss.
Okay. So now, now we have to learn methods of preparation of phenols. Methods of preparation of phenols. Now, whenever you are preparing from phenols, remember you have to have a compound that you want to start with, should already have a benzene ring. So first is from chlorobenzene. Okay, it is like from alkyl halides, but there are two problems. See, we have already learned that CH3Cl plus aqueous KOH or NaOH will give me CH3OH plus KCl. This is a simple reaction that you have learned for alkyl halides, isn't it? A substitution reaction where Cl will be replaced by OH. So if I have a benzene ring, if you remember, we have done this reaction with chlorobenzene. So if I do take chlorobenzene and I react it with NaOH, aqueous, right? There are two problems which happen. One is the reaction cannot take place easily. You need a high temperature and pressure. So you need 623 Kelvin temperature and 320 atmospheric pressure. So this at high temperature and pressure, when you do this reaction, then Cl will be replaced by OH. But there is another problem that you have NaOH. So NaOH reacts with phenol and the product becomes ONA, sodium phenoxide. You don't get phenol, but you get sodium phenoxide, right? Why do you get sodium phenoxide? Because sodium phenoxide is acidic in nature. Phenol is acidic in nature and it combines with sodium hydroxide, which is a reactant, and you get the sodium salt. Now to convert it to phenol, that's why I have to acidify the solution with H plus, and then OH will be replaced by, ONA will be replaced by OH. Okay, so that is how you can, you have to neutralize the NaOH and then you can get phenol. So basically it is by, from chlorobenzene by aqueous hydrolysis. This is also a substitution reaction, but under special conditions. What are the special things you have to remember? That you have to have high temperature and pressure. Why do you need high temperature and pressure? If you remember from last chapter, this CCl bond is difficult to break because of resonance that chlorine engages in with the benzene ring. So this acquires a double bond character, and so it requires high temperature and pressure. And then phenol, which is formed as a result of the reaction, is acidic in nature. So it combines with sodium hydroxide and it forms sodium phenoxide. And that has to be acidified to give you phenol. Okay, so that is a reaction for preparation of first reaction. Now these four preparations are there, which are a little difficult, slightly more difficult. So you have to learn them specially, memorize them and learn them. So the next one is, second one is from benzene sulfonic acid. Benzene sulfonic acid. Okay, from benzene sulfonic acid. Now, how do you prepare from benzene sulfonic acid? First, you should understand what is benzene sulfonic acid. So when you take benzene, right, and you react it with concentrated H2SO4, this reaction you have learned last year with hydrocarbons, then what will you get? You will get benzene ring and here SO3H. This is called benzene sulfonic acid. Right. Now this benzene sulfonic acid when reacted with sodium hydroxide with NaOH and in presence of, you should not, again, what will you get? You will get sodium phenol, but because it is sodium hydroxide, you will get sodium phenoxide. It is always good to write this on the arrow, because if you write on the arrow, the advantage is you will not have to write the byproducts. So if I take NaOH, then you will get sodium phenoxide, same like the previous one. And then when you add H plus, you will get phenol, right? And the byproduct here is sodium sulfite. Na2SO3 is removed and you get ONA. Phenol reacts with NaOH and gives you sodium phenoxide. So then again you acidify and you get the phenol. Okay. Now the next reaction. The third reaction of phenol, or for preparation of phenol, that is from a compound that is from aniline. Now, what is aniline? Aniline is, these are various compounds which already contain a benzene ring. So this is aniline, NH2, right? And when I react aniline with nitrous acid, HONO, this is nitrous acid, right? I will get, what I like to do is I can write it here. In another way, I will write it in a straight line and show. Yes, tell me.
Miss, rather, if, we can react with nitrous acid also, but can't we use Sandman's reaction to convert it to chlorobenzene and then use dose process as we did now? Then from the chlorobenzene, can't we again repeat it and arrive with phenol?
Yes, we can do that. Definitely we can do that. But here, here also, as you do in Sandmeier's reaction, this is what I was going to tell you. This nitrous acid is very unstable. So you always use NaNO2 and HCl, right? Just like I told you in Sandmeier's reaction. So aniline can be converted with NaNO2 and HCl, and keeping the temperature from 0 to 5 degrees Celsius, this aniline changes into this benzene diazonium chloride, N2Cl. This is what? Benzene diazonium chloride. What you are saying also is possible. I just showed you the reaction directly. So I can, instead of doing this, I am showing you now in a different way. I mean, the way you suggested, we can go by that way, benzene diazonium chloride. Now, instead of making it chlorobenzene and then going back to the reaction with NaOH, you can directly from here get phenol, because if I warm it with water, here H2O and warm, right? Then this will directly, N2Cl will be replaced by OH. Okay, so you will directly get phenol if I warm it. So that is what I was trying to show you, that this benzene diazonium chloride, you need not isolate at all. You just take NaNO2 and HCl and heat it with aniline, you can directly get phenol. Okay, so you can, instead of writing the reaction with NaNO2 and HCl, you write a reaction with HONO, and don't write the temperature above 5 degrees Celsius. Then you can directly isolate phenol. In fact, this reaction can be used also to prepare alcohols. And the easy way of writing it is you write it like this: C6H5NH2, and HONO you write HONO. So how will I write? Here you write HONO here. This is a trick to remember: HON and O. So what are the byproducts also you will understand. You will get C6H5OH, which is phenol, plus N2 plus H2. Okay, so any primary amine can be reacted with nitrous acid to give you NH2 will be replaced by OH. But the real mechanism is aniline, always you change it into benzene diazonium chloride and then heat it to get phenol. Okay, so that is what I was trying to tell you. So you don't have to go through Saint-Meyer's reaction, you can directly change it. Okay, so that is now the fourth reaction. So all these reactions are those reactions where the benzene ring was already there. Chlorobenzene to phenol, benzene sulfonic acid to phenol, and then we did aniline to phenol. Okay. Now the next one is, this is an industrial or a large scale preparation from cumene. This is known as the cumene process. What does cumene? Let us understand first. So if on the benzene ring, I have a isopropyl group, right? This one, isopropyl benzene, isopropyl benzene. It is also known as cumene. So this is the starting point of the reaction. Now, first step of this reaction is that you heat it in air in presence of oxygen. So this hydrogen here, it is a tertiary hydrogen. And I told you tertiary hydrogen is always, it can be removed easily. So in presence of oxygen, what happens is this tertiary hydrogen, so this is my carbon, this is CH3, this is the other CH3. This hydrogen here is replaced and it becomes O, O, and H. Not replaced, oxygen. Now this, when two oxygens are attached one after the other, it is a peroxide. So this compound which is formed, it is cumene hydroperoxide. A peroxide is formed. And very interestingly, this compound, when it is an unstable compound, when it is treated with H2O and H+, it breaks down into two very useful compounds. That is why it is an industrial process, because all the byproducts which are formed are useful. So what do you get? You get first one compound which is here. So let me take out that. It is CH3, CH3, C double bond O. What is that? A ketone. This is what? Acetone or propanone. And the other compound is what? Now you can guess. The OH attaching here. So through some arrangements and rearrangements, you get phenol and acetone. Both are useful. So that is the last method for the preparation of phenol. So these four methods are there for preparation of phenol. Now, the first three methods you only use in conversions. How will you convert benzene to phenol? There are four ways of converting benzene to phenol. Benzene to chlorobenzene, chlorobenzene to sodium phenoxide, sodium phenoxide to phenol. Or benzene to benzene sulfonic acid, and then to sodium phenoxide, and then to phenol. Or benzene to nitrobenzene. When you learn compounds containing nitrogen, you can do that. Benzene to aniline, and then aniline to phenol. And then this one also, cumene process. You can actually convert benzene to cumene, and then cumene to acetone and phenol. So these are all four methods of preparation of phenol. Okay. Now, shall I move forward? Children, did you get the notice saying that next week I will not be able to take classes on?
Yes, ma'am.
Yeah. So instead of that, I will take one more class on this Friday. And then next week, I will tell you, I think on 1st, then I will have a class on Saturday. This week on Friday, or is it on Saturday? That I didn't check. But there is a change in schedule. So you will have 3 classes this week to compensate for the classes that I cannot take. I'll be on leave next week. Okay, so now methods of preparation all over. Now we will come to physical properties. Physical properties. So I told you all physical properties depend on what? IMF. What is IMF? Intermolecular forces of attraction. Right? So what do all the physical properties depend on? Intermolecular forces of attraction. So first let us understand what are the intermolecular forces of attraction in case of alcohols and phenols. Now, what is the functional group in alcohols and phenols? All of them contain OH. Okay. Now, what is special about this OH? In case of OH, hydrogen is, so this bond, hydrogen-oxygen bond, is a highly polar bond. Hydrogen is attached to oxygen, which is highly electronegative, and this hydrogen then becomes electropositive. So in this molecules which have such polar bonds, like supposing I see water, HOH, right? This is polar, so this is delta negative, this is delta positive. So the next water molecule, it rearranges itself like this. Now this is positive and this is negative. So there is an intermolecular force of attraction between this oxygen and hydrogen. What do you call this one? Who will tell me? This intermolecular force of attraction. This is also a hydrogen bonding. Very good. This is known as hydrogen bonding. So when do you see hydrogen bonding? You see hydrogen bonding always when hydrogen is directly attached to what? Fluorine, oxygen, or nitrogen. I always say when hydrogen is having what? Fun, F-O-N, fun. Not F-U-N, F-O-N, fun. So whenever hydrogen is having fun, it forms hydrogen bonds. And these hydrogen bonds they are quite strong and the molecules come close. And so they they have higher intermolecular EMF increases, the intermolecular force of attraction increases, and that is when they become, instead of gases, they become liquids. Otherwise, covalent compounds, if their intermolecular force is very weak and they can be gases. But here, wherever there is hydrogen bonding, the molecule will be liquids. So based on this, let us see the alcohols also have a OH group, hydrogen attached to oxygen. So hydrogen is having fun there also. So alcohols also show hydrogen bonding. So the first important thing is alcohols are liquids. Almost all alcohols are liquids. You know alcohol is a gas, right? So if I take CH3, it has how many carbon atoms? 2. And if I take CH3, CH2OH, this is what? C2H6. And this is what? C2H6O. Just by adding one oxygen, this is a gas and this has become a liquid. Why are alcohols liquid? due to H bonding, due to hydrogen bonding. Alcohols are all liquids due to hydrogen bonding. If you go to very high alcohols, right, which have 17 carbon atoms, then they may be waxy solids. Otherwise, all alcohols are liquids. Then the second point is their melting and boiling point. So boiling points are higher than alkanes with same number of carbon atoms. Right? Why? Again, due to hydrogen bonding. Okay, so intermolecular force of attraction is higher, so the boiling points of alcohols become higher. Right? Then the third point is, if you take isomeric alcohols, okay, isomeric alcohols, that means if you take alcohols. So if I take 1-butanol and tertiary butyl alcohol and tertiary butyl alcohol. Okay, so one is butyl alcohol and the other is tertiary butyl alcohol, right, which will have a higher boiling point. Both are C4H10O. So among isomeric alcohols, which will have a higher boiling point? Now
Ma'am,
this
is it butyl alcohol?
butyl alcohol will have, because branched chain alcohols have, the packing is not so good. So as the carbon chain increases, the boiling point of alcohols increases. So straight chain alcohols will have higher boiling point than branched chain. So among isomeric alcohols, straight chains alcohols, they have higher boiling point than branched alcohols. Okay, so straight chain alcohols will have higher boiling point than branched alcohol. Then the fourth important point is that alcohols are water soluble. Alcohols are water soluble. Why? They are water soluble again due to what? Hydrogen bonding. Hydrogen bonding with water. They form hydrogen bonds with water. So you should learn how to write this in the form of, so when you are showing hydrogen bonds among alcohol, this is an alcohol. So you can write continuously like this. So this is another molecule of alcohol, and this is another molecule of alcohol, and this you can show as H bonding, right? And when you show solubility, how will you show? This is alcohol, and you write another molecule of water, and then you write a molecule of alcohol. So they mingle easily because they form not only hydrogen bonds with themselves, they also form hydrogen bonds with water, right? So that is why they are water soluble. So this is for solubility. And this is to show H bonding as IN. Okay, so this can decide or the hydrogen bonding between alcohols, how it affects their boiling and melting points. Now here again, I will talk about phenols also. So the sixth point here is phenols also are water soluble. Okay, phenols also are water soluble, and just phenol, a simple phenol is actually C6H5OH. It is actually a crystalline solid. but with a low melting point. The melting point is only 42 degrees Celsius. So nowadays in Chennai, if you look at phenol, it will be liquid, because if the temperature, room temperature is 42 degrees, then it will be a liquid. Okay. So that is about uh, phenols. Then the last point is, if I take alcohols which are dihydroxy alcohol, if the number of OH groups increase. So say for example, if I have CH3, CH2, OH, and another one is ethylene glycol, 2 OH groups, and the other one is 3 OH groups, glycerol, right? Which will have the higher boiling point. As the number of OH groups increase, the EM hydrogen bonding increases, and so the intermolecular force of attraction increases and the boiling point increases. So here the boiling point is only about 78 degrees Celsius. But here the boiling point of glycerol is 360 degrees Celsius. So much it increases due to hydrogen bonding. Okay. So as the number of OH groups increases, also the boiling point increases. So boiling point depends on the straight chain or a branch chain, or also on the number of carbon atoms in the chain, and also on the number of OH groups. Okay, as the number of OH groups increases, the hydrogen bonding increases, hence the boiling point increases. As the number of carbon atoms in the carbon chain increases, the van der Waals forces between carbon increases, so the boiling point increases. In isomeric alcohols, if there's a branch instead of a straight chain, then the boiling point decreases. Okay, so these are all the physical properties of alcohols. Okay, now we will take the next part. There are a lot of questions from physical properties, so you should be able to understand those things. Now, one more thing I would like to explain here. One more question from here, it is asked, that is from phenols. So you can have different types of phenols. This is one phenol. This also affects the intermolecular force of attraction. This is one phenol which is having a NO2. Let me write here. Orthonitrophenol. This is a nitrophenol. And there is another phenol which is a para-nitrophenol. Sometimes they ask questions from this also in physical properties. So which one has a higher boiling point and why? So here what you have to see is that hydrogen enters into this hydrogen, enters into hydrogen bonding with nitrogen on this side. When hydrogen is attached to an electronegative element, it can form a hydrogen bonding on this end. Within the molecule, it can have hydrogen bond. So when it has hydrogen bonding within itself, you call it intramolecular H bonding, right? So this OH is uses hydrogen bonding within the molecule. So there is the IMF, intermolecular. IMF is what? Intermolecular hydrogen bonding. Intermolecular forces. So if intramolecular hydrogen bonding is there, then IMF, intermolecular forces, they become low. And so the boiling point is low. Because boiling point depends on intermolecular hydrogen bonding. Why there is no intermolecular hydrogen bonding? They're not there because of intramolecular, within the molecule. In this case, so the boiling point of this one will be less than boiling point of this. Why? Because in this case, there will be intermolecular hydrogen bonding quite extensive, because here NO2 and here OH. So this hydrogen will have hydrogen bonding with this nitrogen, and this hydrogen will have hydrogen bonding with. So there will be stronger IMF. IMF will be stronger. And because of that, the boiling point of para nitrophenol will be more than boiling point of ortho nitrophenol. Okay, so sometimes they twist the question and ask like this also, so you should know. Okay. Now the last part for today. I'm sure all of you are tired, so am I, but we will just finish the last 10 minutes. For a change, let me see who all are there and who all left. All are there. Very good. Now we will take the chemical properties. Of alcohols and phenols, we will take the chemical properties. Now the first reaction of alcohols and phenols that we need to take is acidic nature. Let us talk about the acidic nature of alcohols and phenols. Okay. Now, if there is something which is an acid, it can show what reactions? It can show 3 reactions. Okay. So all acids, if I take an acid, you know, and I can write here the reaction with sodium, sodium hydroxide, and sodium carbonate. So if I take any acid, let's say for example, any acid like hydrochloric acid or acetic acid, all acids react with metals, you know, and displace hydrogen. So what will happen? The acid will react with sodium and give out hydrogen. So reaction will take place. So acids will react with sodium and give what? Hydrogen. Acids also react with alkalis to give what? Salt and water. So what will you get here? Salt plus water. Here you will get salt plus hydrogen. And what do you get in case of carbonates? Anybody who can tell me? An acid reacts with carbonate to give me what? Any acid. Have you seen a reaction of sodium carbonate?
Salt, ma'am.
Yeah, salt, NaCl, salt plus what? Water plus carbon dioxide. Do you remember this reaction? Have you
Yes,
learned
ma'am.
it? Yeah, so carbonates, they always react with dilute acids and they give carbon dioxide. So similarly, acids in organic chemistry also will react with all, and here you will get salt plus water plus CO2. So a strong acid, a true acid will combine with all of them. It will combine with sodium to form salt and hydrogen. It will combine with sodium hydroxide to give salt and water. It will combine with sodium carbonate to give salt, water, and carbon dioxide. Right? Now we are looking at alcohols and phenols. So let me first take alcohols. Okay. So alcohols, what they do? They react with sodium. This reaction takes place. They react with sodium and slowly, not like reaction of sodium and water. They react slowly with sodium and give out hydrogen, salt plus hydrogen. They don't react with sodium hydroxide. They don't react with sodium carbonate, right? Now what about phenols? Phenols, these are practical observations. Phenols react with sodium and liberate hydrogen. They also react with sodium hydroxide to form salt and water, but they don't react with sodium carbonate. Okay. So by looking at these 3 observations, what can you say? That alcohols are acidic in nature. Then comes phenol, and the most acidic are acids. So acids are strongest and alcohols are the weakest. They have the weakest acidic nature. Okay, so alcohols are the weakest and acids are the strongest. Okay, so carboxylic acids, they are strongest acids and the weakest of them are alcohols. Now let us understand what is the meaning of acidic nature of alcohols. For any compound, what does the acidic nature mean? So acidic nature means that alcohol, if I write a general formula of an alcohol, what is it? ROH. Its acidic nature means can it give H plus? So RO minus and H plus. Can this reaction take place? It is a weak one, so I can only write it. All organic acids are also weak acids, so I will write a reversible sign. So can it form this? Now for phenol, what will I write? C6H5. Let me write the benzene ring only. C, this is the benzene ring and this is OH. This to some extent gives me this O minus and H plus. Because what is the definition of an acid which gives H plus ion in solution? So phenol, it only say, I am only saying alcohols give H plus ions in solution. Or phenols also give H plus ion in solution. Now, why are phenols more acidic? That to understand that only I have written these two equations. Now here, this ion which is formed here, right? This is called alkoxide ion. Alkoxide ion. And this ion that you get here, this is called phenoxide ion. Now, how will I know which is more acidic? Wherever the H plus ion concentration is more, that will be more acidic, right? So to prove where my H plus ion concentration is more, now you look at phenoxide ion. Now this phenoxide ion, it stabilizes by what you call resonance. You would have learned about it last year, right? So due to resonance, the phenoxide ion is stable. Alkoxide ion does not show any resonance. So the phenoxide ion is more stable than the alkoxide ion. So the equilibrium is more to wherever there is more stable. This is phenoxide ion is stable. Stable due to resonance. So if the ions on the right side are more stable, the equilibrium will be more to the right. So H plus ion concentration for phenols will be higher and hence phenols will be more acidic than alcohols. So the first important point is alcohols are acidic. First is alcohols are acidic, right? Because they give H plus ion in solution. Second is alcohols are weaker acids than phenols. Why? Because phenoxide ion stabilizes by resonance. Stabilizes by resonance. Did you understand? So the first thing is alcohols are acidic. Why? Because they give H plus ions in solution. Alcohols are less acidic than phenols because phenoxide ion stabilizes by resonance. Phenoxide ion stabilizes by resonance. Now, the next thing that we need to understand about acidic nature, that is to compare the acidic nature of primary, secondary, and tertiary alcohols. Now you have to now answer the question. So I'll write a primary alcohol, CH3, CH2, OH, right? Here I will write a secondary, CH3, CH, O and H. Here CH3, CH, O and H. And here CH3, C, CH3, CH3 tertiary, O and H. Why I have shown this OH bond a little longer here? Because breaking of this bond will decide which alcohol is more acidic. All right. So just like I showed you the stability of the alkoxide ion here and phenoxide ion I compared, and when I said the phenoxide ion is more stable due to resonance, now stability of the ions which are formed will decide which alcohol is more stable, which alcohol is more acidic. So wherever the alkoxide ion is more stable, there the alcohol will be more acidic. So how will I decide? Now here you decide the stability, unlike phenol where we have the resonance, here you decide stability based on plus I effect. Okay, plus I effect. So there are several ways of explaining this. One way of looking at it is, which I like and which is easy, that oxygen is pulling electrons towards itself. Anyway, oxygen is pulling electrons towards itself in this bond, because of which alcohols are all acidic. H plus ion is given out. So H plus ion is, oxygen is pulling from here, and oxygen is pulling from here, and oxygen is pulling from here. The pull of oxygen is same, but what is acting in the opposite direction? Here, what is acting is the opposite direction is a plus I effect of this CH3. Here, there is a plus I effect of 2 CH3. And here, there is a plus I effect of 3 CH3 groups, right? So here, where will be the plus I effect more? The plus I effect is maximum in tertiary alcohols. So what is the plus I effect doing here? It is reducing the effect of the oxygen, the pull of oxygen. Oxygen is making the bond polar, and plus I effect is decreasing the polarity of the bond. So what will happen in tertiary alcohols? The polarity will be the least. And because of that, tertiary alcohols will be the least acidic, and then secondary and primary alcohols will be the most acidic. So the plus I effect, what does it do? It decreases the polarity of the bond. Of which bond? O and H bond. It decreases the polarity of O and H bond, right? Because it works in the opposite direction to the direction in which oxygen increases the polarity, right? So higher alkyl group decreases the polarity of oxygen-hydrogen bond in alcohols, and because of that, primary alcohols are more acidic than secondary, and the weakest acids are tertiary. Did all of you understand this?
Yes, ma'am.
Yes, yes. So now I will stop, and we will do a little more in the next class, and every one of you should switch on your camera for a moment and say bye and then leave.
Ma'am, I have Wi-Fi problems, ma'am.
Okay, no problem. Hariharan has Wi-Fi problem. Okay, Chitra, bye. Thank you for bye. Thank you very much. Sai Kalyan, bye. Thank you very much, Sai Kalyan. I've increased your marks. I've increased your marks. I've informed them. So they will increase them. Did you get a note that your marks are increased?
I will check now.
Okay, I have informed them. Now you will have 61 marks.
Okay, miss.
Very good. Now, on 18th, I'm meeting your parents.
Okay, miss.
Hariharan, bye.
Bye, ma'am. Thank you, ma'am.
Thank you very much. Sanjay, bye. Hari Raghav, bye.
Thank you.
Bye. Bye. Sanjay, are you there? I didn't hear your voice. Sanjay. Sanjay.